हेलो एवरीवन, गुड मॉर्निंग एंड वेलकम टू माय यूट्यूब चैनल टेक इन मैथ्स। मैं निवेश कुमार दास इस वीडियो में जेईई मेन 31 जैन 2024 शिफ्ट 1 डेफिनेट इंटीग्रेशन का क्वेश्चन को कवर करने जा रहा हूँ। सो द क्वेश्चन इज हियर, let s equal to -1 to infinity in open interval, function defined from s to r is a real number. So fx is what here, -1 to x and e to the power t minus 1 whole to the power 11, 2t minus 1 whole to the power 5, t minus 2 whole to the power 7, t minus 3 whole to the power 12, 2t minus 10 whole to the power 61 dt. What is p here? The sum of squares of values of x where fx attains local maxima on s, and q sum of values of x where fx attains local minima on s. Then the value of p square plus 2q is, we need to find this one. So here we will apply the Leibniz rule first to find the first derivative f dash x, then first derivative test to find the local maxima and local minima. Okay, then we will evaluate the p square plus 2q. Okay, so what is v fx here? Fx we have given here is fx is -1 to x, so I write here -1 to x, and e to the power t minus 1 to the power 11, 2t minus 1 to the power 5, t minus 2 whole to the power 7, right? Here is power is 7, and t minus 3 whole to the power 12, and 2t minus 10 whole to the power 61 dt. So applying Leibniz rule, so differentiating this f dash x, this is d by dx. So here it is e to the power t minus 1 whole to the power 11, 2t minus 1 whole to the power 5, t minus 2 whole to the power 7, t minus 3 whole to the power 12, and 2t minus 10 whole to the power 61 dt. Right. So now when we apply the Leibniz rule, so what is basically the Leibniz rule is, will replace the upper limit. So here is integration -1 to x, so antiderivative, this is basically derivatives of antiderivatives. So what is this rule here? When you have to differentiate this integration, so we'll replace this t by the upper limit, that is gx, and then differentiate gx, that is g dash x, then minus replace this t by the lower limit hx, and then differentiate the lower limit, that is h dash x. So we'll apply here this rule here. So f dash x is basically here, if you replace here, so it will becomes e to the power x minus 1 whole to the power 11, e to the power x minus 1 whole to the 11, 2x minus 1 to the power whole to the power 5. Next one is x minus 2 whole to the power 7, then x minus 3, this is what here, x minus 3 whole to the power 12 and then 2x minus 10 whole to the power 61, and then differentiating the upper limit, that is x, right? So derivative of x is 1, but for lower limit it is constant, that is -1. We will replace that x by -1, but when we differentiate -1, that becomes what, 0. So basically f dash x is this one. Now for maximum or minimum, we will equate the first derivative f dash x. For maximum or minimum, we equate this f dash x to 0. So we equate this f dash x to 0, and basically f dash x is what here, f dash x is e to the power x minus 1 to the power whole to the power 11, right? And 2x minus 1 whole to the power 5 x minus 2 whole to the power 7 x minus 3 whole to the power 12, and x 2x minus 10 whole to the power 61 to 0. So each factor will be equated to 0. So e to the power x minus 1, when equate this to 0, so we get e to the power x equal to 1, and we can write this e to the power x equal to e to the power 0. So the stationary value of x is 0 here, one of the stationary value is x equal to 0. The other factor is 2x minus 1 to 0. So from here we get x equal to 1 by 2. So I write here x equal to 1 by 2. Then we have x minus 2, when we equate this x minus 2 to whole to the power 7 to 0. So from here we get x equal to 2, x equal to 2. Next we have x minus 3 to 0, so we get x equal to 3, right, x equal to 3. And the last one is 2x minus 10 to 0, 2x minus this factor to 0, so x equal to 5, right. So all these are the stationary values. So we'll plot this on a number line. So I just plot this on a number line, right. So this is a number line here I drawn. And what is the value here? First one is 0, then we have 1 by 2, then we have 2, then we have 3, and then we have 5, right. All this value, okay, a stationary value. So 0, 1 by 2, 2, 3, 5, okay. So x, one thing is you need to notice that x minus 3 whole to the power 12, this will be always positive, right, is always positive, okay. So always positive. So accordingly we have to just draw the wavy curve, right, wavy curve. So this will be what? Positive, right. This 5 to infinity, this will be negative, here it will be negative as well, right. Then it will be changed because this will be always positive. So after 5 the interval 2 to 5, right, this will be negative, this will be what? Positive, this will be negative, and this will be positive, right. So this is your wavy curve, right, wavy curve, okay, wavy curve. 1 minute, let me write this clearly, okay. So wavy curve we have drawn, wavy curve graph, wavy curve, okay, wavy curve, okay, fine. So here you need to just first derivative test, we are going to find the local maxima and local minimum. So you just recall this point here. If dy dx changes its sign from positive to negative as x increases through a stationary value of x equal to a, then the function attains a local maxima at x equal to a. And if it changes, dy dx changes its sign from negative to positive as x increases through a stationary value of x equal to a, then function attains a local minimum at x equal to a. So positive to negative, where we find the positive to negative, this is a point where we find the positive to negative, right, where we find the positive negative. So at x equal to 0 it attains the maximum, right. It is negative to positive, so at 1 by 2 it is minimum, right, minimum. Here again at 2 you can see positive to negative, so at 2 it is maximum. Then we have negative to positive, so at 5 it is what here? Minimum, right, minimum. And since at 3 the sign does not change, so this is a point of inflection, okay, this is a point of inflection, that is neither maximum nor minimum, right. At this point neither maximum nor minimum, right, that is the point of inflection. So the points where we attain the maximum, right, maximum value, right. So maximum values at maximum value at x equal to 0, first one x equal to 0 and another one is 2, and minimum, right, minimum value at x equal to 1 by 2 and 1 by 2, x equal to 1 by 2 and 5. So these are the points where we attain the maximum and local maximum or local minimum, right. Local maximum at 0 and 2 and local minimum at 0, 1 by 2 and 5, right. So we have here in the question is what? P. What is P? Sum of squares of value of x where fx attains a local maxima on S. Sum of squares. So P will be what here? P will be here. P will be sum of square of the value of x where it attains the local maxima. So 0 and these are the points where it is what? 0 and 2. So square, sum of square of this two value, that will be the P. So 0 square is 0 and 2 square is 4, so 4. And Q is what? Q, if you see the Q is what here? Sum of values of x. where fx attains a local minimum on S. So sum of values of x, is what here, that is here 1 by 2 and 5. So we just add this 1 by 2 and 5. So this is what here, 11 by 2. We need to find what? We need to find the p square plus 2q, So p square plus 2q, p square is 4 the whole square, right? P square is what? 4 whole square, right? And then 2 into q, and q is what? 11 by 2. So 2 and 2 get cancelled. This is what here, 16 plus 11. So this is what? 27. So answer is 27. Okay. So the value of p square plus 2q is 27. Hope you will be clear with this solution. I will come with the new sets of question. Please consider subscribing my channel. Thank you. Bye bye. Take care.